started. Done. Good morning, everybody. Let's work hard. This is the lesson for today. I don't feel good in my stomach, but we wanna work. And I will tell you why. We draw this plot. X was not a 1, and my colleagues were like, okay, can we have a case where even if the objective function doesn't make sense? Because it is actually a good question. Why are we getting this x greater than 1 all the time for free, right? We only solve the problem for obedience and PSD, and sometimes for optimal revenue. For example, we get it, we do it for payment as well, but it is 1/2 of the payment. The other half of the payment is x being greater than or equal 0, or for IC or IR, x being greater than or equal 1. We always get it for free without, like, we relax the problem, we remove the x greater than or equal 1 constraint, we solve the problem, and it turns out that the x is always greater than 1. Is it because of the objective? Why can't we have cases that x equals 1 is binding? Or we can have cases that we are solving it for obedience and PSD, x turns out to be less than 1, and we have to add the extra constraint where x is greater than or equal 1. So first of all, let's see if we can get a couple of suggestions. One is setting eta to infinity. One is set eta to infinity so that it is only the eta was effect of firms, right? Or effect of consumer. Let me see. WT. Yeah, eta is consumers. Eta infinity. So what will be maximizing welfare of consumers? But we are saying, okay, what if we want to maximize welfare of consumer? Why? Because it's coming from this point that, well, consumers and the firm's utility are kind of against each other. So if I want to maximize, it was the initial reason we started this consumers utility micro foundation, that we said, okay, consumers utility and seller's utility or firm's utility are kind of against each other. Probably if you want to maximize the overall welfare, we will end up having the X binding. Well, if you want to maximize WC, and then if you want to maximize WC, just in order to see WF decreasing, well, just be honest with yourself and minimize WF. Go more, what is it? Intense. WF. And 3, what is 3? Is that now that I'm bullshitting and minimizing WF, why should a platform decide to minimize the welfare of the data buyers. So now that you want to try everything, minimize welfare of the firms, let's say you just want to minimize any linear function of sigma AIJ, sigma AI theta I, and sigma AI omega once we apply obedience. And is there, if there is any linear function? And then you may say, okay, now that we turned it to any bullshit linear, why can't we add payment included? That can be mix of like revenue kind of thing. I will go with option 3 because it also includes option 1 and 2. Option 4 is a much bigger space. So what I want to say is, let's say we want to maximize what are the coefficients I can put? So we want to maximize, let's say eta, eta A sigma AI AJ plus eta X sigma AI theta I plus sigma eta Y sigma AI omega with respect to the, do I have them here maybe? Exactly, I have them here. And what about once we substitute the two values of sigma AI theta J and sigma AI squared based on the other two? Okay, we have them. Yeah, I want to have that. Yeah, that's the better concept. So this is the first PSD, second PSD. Just we got rid of obedience, substituted the value of sigma AI squared and sigma AI theta j based on the values of sigma AI theta I, AI omega, and AI aj. Perfect. And so we know that if eta A by the way, how did I write the code for consumer's utility? Okay, the ellipse equation does not change. And it is the linear. Okay, I will check it later. It's okay to check it. Okay, how do we write the ellipse equation? We know one of the PSD constraints must bind. All right, even when eta A is 0, we can have the situation where one of them is binding, and so in the first one we have n minus 1 r minus 1, which is negative because r is less than 1 over n minus 1 all the time. And on the second one we have n minus 1 times 1 plus r, which is positive, the coefficient of sigma aj, which is positive. So if I multiply the first one by n minus 1 times 1 plus r, and the second one by n minus 1 r, I can multiply the first one times n minus 1 plus r. Second term I can multiply by minus n minus 1 r minus 1 because it is positive. Now I will have one plus r, I agree, 1 plus r, what is this there? One plus r, n minus 1 of the n minus 1, so okay, 1 plus r squared, r squared var theta. Okay, r squared var theta sounds right. 1 plus r sounds right. F minus r, this part, t var theta x. T var theta x is sigma I theta I, right? Yes, t var theta x is sigma AI theta I. Is it f minus r though? If I divide it by n minus 1, okay. Yeah, so we have 1 more n minus 1. So it's r minus f x minus t. Is it minus? Minus Okay, over n minus 1, that's true, plus f minus r f minus r, right? R squared sigma theta I squared 1 plus r t bar theta x minus t sigma t bar theta. So just this part, it is f minus r. F minus r. Well, that's right, that's all we need. Plus f minus r and var omega ys s var omega y is a better term, t var theta x is a better term, squared less minus what is the right hand side? Sigma ij goes away, n minus 1 plus r s sigma I omega n minus 1 times 1 plus r minus n minus 1 r, which goes away, which is n minus 1 plus 1, which is n. I don't see over n here. Did we divide it by n? No. N's s sigma I omega. Okay, I get the minus sign. I get s, I get this. I don't get 1 plus f though. 1 plus f is n over n minus 1. Are we dividing everything by n minus 1? Okay, I have to check that. And for t, the same thing. Yeah, t bar theta x is better than ys bar omega y. It should say s bar omega y. Alright, and for, let's make sure if we have the coefficient right for the first. We should have it divided by n minus 1. N minus 1. Okay, we have r squared okay, no. R minus f sigma I theta I plus ft sigma theta I squared plus, okay, that's it. It will be, if I divide it, do we have 1 plus r over r squared bar theta times f minus r t sigma theta I minus ft. Perfect, yeah, we have the division by n minus 1. So elliptic equation is true, and we know that for you tell me first best, second best, no. Okay, we want to have Lagrangian coefficients, lambda greater than or equal 0 and nu greater than or equal 0. And we know that if eta A is positive, what it means, eta is positive, and we want to maximize n minus 1, r minus 1 is negative. So we want to make eta is positive, we want to increase our sigma AIAJ, then what is giving us upper bound is first PSD. First PSD binds eta A is less than 0, we wanna make sigma AIHJ as small as possible. What is giving us lower bound is the second PSD. And now we want to say just take a look, do the stationarity constraint. I think I can take a look at the welfare optimization. It will be very similar. And I want to use more pages. That's what we get. So let's do it. Hopefully this is the last time we are doing it. By the way, code for the consumer's utility was more. I was not. Fuck, my hand is dying. Which one was the one that we used AB? We used ChatGPT's help. Oh, we used Nu. Okay, Nu is okay. Oh. This cannot be it. Yeah, it's the benchmark. Okay. So round Lagrangian round sigma AIAJ equals eta A plus lambda n minus 1 r minus 1 plus nu n minus 1 1 plus r should be 0. Round L round sigma AI theta I eta x plus, okay, I think this motherfucker. I think this one is around sigma I omega. So around sigma I theta I is a bit nasty. AI omega. Let's do the sigma I omega first. It will be eta y plus s lambda plus s nu minus exactly the term here we have minus plus nu times s minus 2n sigma omega squared sigma AI omega, right? Eta y s lambda nu s minus 2n over sigma AI omega equals 0, and round L round sigma AI theta I eta x plus eta x plus t lambda minus something lambda something big plus t nu minus nu something big equals 0. So you can say eta x plus t lambda plus yeah, because here we have t sigma AI theta in the object. Here we are saying eta x. Alright, t nu equals this motherfucker 2 lambda whatever it is. I have it here too. 2 lambda f minus r over r squared sigma f minus r sigma AI theta f t sigma theta I squared plus 2 nu 1 plus r over r squared sigma theta I squared 1 plus r sigma AI theta. Perfect, that's it. 2 lambda f minus r squared theta I squared f minus r sigma AI theta I minus ft sigma theta I squared plus 2 nu um, 2 nu, what is it? 1 plus r over r squared sigma theta I squared. 1 plus r sigma ai theta I minus t sigma theta I squared. That's it. One other thing, let's make it eta x t sigma theta I a theta I. It looks better. And eta y s sigma a omega. So the same thing holds almost everywhere. I need to add one s. I need to add one t here. I want to add one t. Perfect. And now we have a stationarity. Nu, first of all, we usually compute nu based on lambda. Nu will be eta a minus eta a plus lambda 1 minus n minus 1 r over n minus 1 1 plus r, which should be greater than equal 0, and therefore we can say lambda should be greater than or equal eta a over 1 minus n minus 1 r. So if eta is positive, we can see that lambda is positive, which means first best is binding. First PSD constraint is binding, as we knew. Second one gives us sigma ai omega based on the rest. What is it? S eta y plus s lambda plus nu, which is minus lambda and x comes from this one. How do we compute x? So we have also sigma ai theta I based on lambda, even though it looks very creepy and nasty. X is, how did I compute this? Right, doesn't matter. I will compute it again. S lambda plus just compute it based on nu. I don't wanna, nu S eta y plus lambda over nu equals 2n over sigma omega squared sigma ai omega minus s therefore sigma ai omega is s eta y plus lambda plus 1 over not plus or plus nu over nu times 2n sigma omega squared. Is it the same formula? And okay, let's have better format. Sigma I omega over S omega squared will be n eta y plus lambda plus nu over 2n nu. And nu is greater than 0, right? Unless, let me see, y is 1, which is eta y, plus lambda plus nu over 2n nu. Alright, this is true. But what if nu is 0, which means second PSD is not binding, which can be the case. Why didn't we ever have it? So you're saying second PSD is always binding? Well, if we are on the ellipse, yes, second PSD is also binding. If we have interior point solution, assuming eta A is positive, by the way, eta A is positive, first PSD is binding, second one may not bind. We have an interior solution. Then the algorithm is different. Then we don't need to use the hyperbolic exactly. So then we are here. Else, interior point, that point like nu is 0 and we know what's up. Xi, we know xi, we know eta. We don't need to compute. Perfect. And so that's one thing. Let me write them down here. Lambda equals eta A over 1 minus n minus 1 r y equals eta y plus lambda plus nu over 2n nu, and x. For x, we are doing something just based on nu and lambda. We can go ahead and do something. For x, I can say t times eta x plus lambda plus nu equals what about the t? Nothing. Yeah. So if I divide it by t, it's all good. Alright. 2 lambda f minus r over r squared times 2 lambda f minus r over r squared f minus rx and minus sigma theta I cancels out this minus f plus 2 nu 1 plus r over r squared times 1 plus r x minus 1. So equals x times 2x over r squared 2x over r squared lambda f minus r squared plus nu 1 plus r squared minus 2 lambda f minus r over r squared minus 2 nu 1 plus r over r squared. So what will be the final thing? Seems we are going to do that. So in the denominator we have 2 lambda f minus r squared plus 2 nu 1 plus r squared. Perfect. Then we multiply the whole shit in r squared. And in numerator we have, what is the coefficient of r squared? L plus nu plus eta x. But instead of 1 we need to have eta x plus 2 lambda f minus r plus 2 nu 1 plus r. Perfect. So change will be very minor. X is eta x plus nu plus lambda r squared eta x plus nu plus lambda r squared plus 2 lambda f minus r plus 2 nu 1 plus r 2 nu 1 plus r 2 lambda f minus r eta x nu lambda r squared over 2 lambda 2 lambda f minus r squared plus 2 nu 1 plus r squared. Sounds perfect. Let's run the code. And then we can find eta. Hopefully we can find some x less than 1. So everybody's happy. The elliptic doesn't change. And it's interesting that it's saying eta x is 1. Where does eta a shows up? Oh, in lambda. Eta a only shows up in lambda. Alright, that's interesting. Y doesn't change. Y, okay, it's just eta y. X is eta x. So crazy objective. Crazy objective. And we wanna say the same code. Eta x, eta a. Just one thing, once eta a is positive, it's kind of obvious what's going to happen. Once eta is negative, what's gonna happen? Same thing holds. Lambda cannot be negative. You know what I'm saying? Lambda cannot be negative. So lambda is non-negative, n minus 1, r minus 1 is negative, 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 plus nu will be positive. How did we say lambda is this, by the way? Oh, what's up? Ah, wait a second. Alright. Is that nu 0? Wait, how did I compute that? Then eta is... Wait a minute, where did I compute this one? That's so stupid. I just assume nu is 0. I was wrong. Why is it? That's true. Eta phi plus lambda plus nu over. This is true. X is true. But computing lambda was totally wrong. So from the first one we have. This is so wrong. If second PSD is not binding, nu is 0. That's it. In general, so eta is positive. First PSD binds. So first PSD binds doesn't mean that lambda should be positive. No. Okay. Who said that? So this is the equation we have. Am I missing something? Yeah, from the first one you can compute nu based on lambda. That's all you can do. Okay, I need to. Here we don't have anything. I think I put it in the trash. Eta A plus lambda n minus 1. Okay. R minus 1 plus nu n minus 1. 1 plus r equals 0. Then nu is 1 minus n minus 1 r lambda minus eta A over over so nu changes with eta A. Now you have different 1 minus n minus 1 r lambda minus eta A over n minus 1 1 plus r. That's it. Okay. Yeah, then you want to say lambda should be great because nu is non-negative. Nu equals 1 minus n minus 1 r lambda minus eta A over n minus 1 1 plus r. Then you say nu should be greater than or equal 0, then lambda should be greater than or equal eta A. That's the only thing. Eta A over 1 minus n minus 1 r. That's it. That's the starting point of the hyperbolic curve. So eta A and if eta is negative, you can just start lambda from 0. Now it makes sense. Perfect. It's x eta y. And we don't care. Eta a is something. What is a good eta a? For example, in the welfare case, it is n-1r, which is something like n-1r depends on r. It can depend on r. Alright. And that's good to know. We can just put it in the, it doesn't cause us problem. Actually, I can change by r. And what is it in the consumer's utility? So we have the formula for nu. If we compare it here, nu is 1 minus n-1 r lambda, which is f minus r lambda minus eta a over over 1 plus r, right? So minus r, sorry, minus utility, it gives us eta a over n-1 equals r 2 minus eta 2 plus eta. So eta is usually a function of r. Perfect. Eta is a function of r, like a linear function of r usually. Even eta a, eta x, eta a, eta x, eta y can be functions of RST. Perfect. Because we are solving the problem for different values of r, we usually have like an eta oh my god. Elliptic equation does not change. But here, I removed the eta here and I just put it in here, eta x. For example, r eta x is, for example, I don't know, 1, eta y, or like t, no, eta y equals, I don't know, 1. So what was formula for nu? It is, oh shit, sorry. Here. All right, I will be back in a second. All right. It was n minus 1r, right? I mean, if you want to go against due to the welfare of the firms, the worst thing, for example, for them will be also RST is 1. Hyperbolic. Let's go. What is left here? Nothing is left here. Here is bullshit. Cancel. What is it? Yeah. So I set this to 1. Eta I don't know. Okay. Eta x, to be honest, maybe you want to choose it minus 1. So in general, we don't want to make it big, but there are so many, like PSD puts different coefficients in front of it. It's not easy to say. However, we can change it. Eta x, eta y. So let's say this is minus n minus 1. Okay, if you wanna minimize the firm's welfare, these all should be minus 1. Nu is this. Nu should change. Nu is f minus r lambda minus eta a. F minus r f minus r lambda minus eta a over 1 plus r. Y is eta y. Instead of 1, we need to have eta y plus okay, so lambda should be greater than this. Nu is greater than, once lambda is greater than this, nu is non-negative for sure. Y is eta y plus lambda plus nu over 2n nu, and x is this L should change to eta x. Eta x plus nu plus 1 r squared not plus nu plus L. Oh, that was lambda. Alright, this is L. Eta x plus nu plus L r squared. Where is the r squared going? Oh, this is x. Rx eta x plus nu plus lambda r squared r squared plus 2 lambda f f minus r 2 nu 1 plus r over 2 lambda f minus r squared plus 2 nu 1 plus r squared. Return x and y. Perfect. And then we want to say elliptic doesn't change. I will have maybe our welfare has a minimum. That's something possible. Where is this coming from? Maximum of, okay, instead of here a lambda should be eta a. Why did we separate competitive from collaborative? Should not make a change. Well, the corner should change for sure. This I want to be minus 1 plus epsilon. And this should be eta a f eta a over f minus r. F well, we know what eta is. Okay. Yeah, give me eta a. So eta a is just, let's copy it here. Who cares? Eta a equals. That's a bit weird that we have to put both of them at the. I can take it as an input to the hyperbolic. That can be an option. Let's do that. Does our code look better? It's what is it? What is an action? Eta x. Makes sense. Alright, now it's f eta a over f minus r. Lambda, if eta is negative, lambda will be 0 minus eta a. If eta is negative, right? Lambda will be 0 minus eta a, lambda nu b will be positive. Alright. F minus r plus epsilon f eta a over f minus r plus epsilon, and well, maybe plus epsilon should be outside the maximum. No, it's not a problem. Both cases doesn't matter. Hyperbolic a and r. Okay, now we need to change control f. First of all, let's find any eta. Theta, okay. Now we have to go to our structural result and see what's what. That's a good one. This is also theta. Yeah, in the optimal revenue we have over x. It's a cubic equation. I don't want to inject or insert payments, to be honest. So if eta a less than 0, a greater than or equal to 0. So if eta a is less than 0, let's go to our round f. Where is it? If this is positive, positive is 19. and we have square root of f epsilon over r squared. Positive f epsilon over r squared. And if eta is negative, f minus r is involved, and 1 plus r. Perfect, that's it. And hyperbolic. F minus r. This all sounds good, to be honest to me. Hyperbolic. Now we need to change hyperbolic. Eta x, eta y, right? I don't know about this one. Sounds better. Hyperbolic. Where is the next hyperbolic? This time P and R. Again, P and R. Then we have CNR, and then we have alright, this one is okay. This one is okay, okay. Perfect. And this is the code. Now we wanna run it. And for that, I wanna why did I put it here? Yeah, it should be here. It should be run with consumer's utility. Can I move? Perfect. For welfare, why did we? Okay, competitive. I don't remember why. A is R over F minus R. What is that? But this is just because eta A is R, right? N minus 1 R. Isn't it the same here? Where is it? Oh, not this one. N minus 1 R. N minus 1 R. N minus 1 times F will be R over F minus R. Perfect. What's wrong? X and Y. Oh, R is the problem. So first of all, let me maybe R0. Okay, X and Y. What was X and Y? R. Again, R. R is this shit. That's fucking weird. Oh, it is below 1. Ah, fuck. It is X. Am I plotting X or log of X? X. We made it, guys. We made it. It's like barely above 1. It's below 1 all the time. Ah! What happened? Dude, what did you do? This is bullshit. This is also bullshit. Um, Perfect, guys. Let's do that. Let's celebrate it and send an email to everybody to let them know. Oh, it's the last time I'm looking at this problem. Great news. Who minimizes the firm's welfare? The firm's welfare. We have x less than 1. Find Did I did too much apps? Uh, right. Snipping tool. benchmark, not benchmark, but it's a benchmark. Set. Perfect, guys. And 1 hour 30 minutes. Perfect. Let's do shit. Counter. I want to play counter. I'm really happy I woke up early today morning. Just my body didn't want to stay in the bed. Dude, these days I'm sharp. So we play 1.5 rounds. And then I want to play. No, I want to go over writing down. It's writing down stage. I don't think there's any point in thinking more. We want to set up our model. And also we want to ask, what is our main question? How it relates to it. Let's just come over here. God. Hit my leg. That was phenomenal. Come here, bird. Headshot. This is my fucking best gun. Oof. Okay. Give me a second. Okay, really constrain solution right. Oh, okay. That's a good point. Oh, okay. So we want to make x equals 1 and so add the fine. Yeah, then we want to do the constraint one that x is 1, right? We always had this question, well, why is our x less than greater than 1? We got getting it for free. Now we want to have it. Now to find the optimal problem, optimal solution, we need to have a case that we need to have a case where yeah, like this is not the optimal welfare anymore, and we will do that. Yeah, let's do it. How can I do that though? Just x is 1. Well, we need to add the constraint x greater than 1. But we need to add the constraint x greater than 1. How does it change? The elliptic stays the same. And well, does it become x equals 1? Oof, brother. Ah, shit. Does it become x equals 1? That we are adding this extra constraint to our problem. Where are they shooting? Extra constraint. We are adding this extra constraint. You know, if we remove, we have to make it x equal 1 at least. Motherfucker, why are you there? Yeah, it's actually what a cat behavior. He's killing everybody. X should be 1, and then we can do it. So, oh, the cat is still there. Alright, I will kill you this time, motherfucker. Bitch. Alright, it was funny until we find you. Bitch, get the fuck out. My gun was stronger. These fucking losers go hide here and there. They think they are anybody. They think they're anybody hiding. Oh, again you. Don't hide. One time you hide. It's just, we are not dumb. We are fucking human beings. Look at that. Haha. Jump up there. Oh shit. Jesus. Who is shooting? Fucking this fucking cat, no. Ah, he has a beef with me now. That's the situation. Because I killed him twice right at his home. Oh shit, this motherfucker. Ha! You fucking loser. Oh, you're there again? I'll kill you again. You're easy food for me now. That's so dumb of you going hiding there. Alright. That's a fair game. shot. Ha 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 ha. Alright, I like the pool. I like the shoot. Actually, we don't need to play. That's it. That's the. What we need is. Okay, does it x become 1? In general. But the problem is complex. So the problem is actually linear. So you are adding extra. It's not linear. It's a convex problem. It's a convex problem. Jesus. Ah! This motherfucker is just standing still. I don't like that. There we go. From that distance. Jesus. Where are these? Let's take a break. Okay, this was the fucking break actually, but that's the problem.